So with forces practice, it's helpful to look at forces with more, or look at objects with more than one force. Go ahead and for this one, set up the sum of the forces and solve for the acceleration. So draw the forces, set up the sum of the forces in the x equals ma in the x, and then solve for the acceleration. When you're ready to check, you can hit play to continue. All right, so we've got friction going back, normal force going up, force of gravity going down. Those are balanced. And the x, positive force applied plus the negative force of friction equals ma. And we add them up, and we should get an acceleration of 0.091 meters per second squared after we get the net force. All right, so for this one, we have our object, the force applied, 60 newtons to the right, and it's going at a constant velocity, and we want to find out what is the force of friction on this box. So yeah, go ahead and set up your forces, do the sum of the forces, and set this up, and then when you're ready to check, you can hit play to continue. So go ahead and pause. All right, so this is more conceptual than anything. Normal force, force of gravity are balanced. Force applied and force of friction are set up there. The acceleration is 0. Therefore, the force applied equals force of friction. And so this goes back to Newton's first law. For an object in motion will stay in motion at a constant velocity as long as there is 0 net force. And that's what we see here. All right, why don't you go ahead and try this one here. We have an 1,800 kilogram car. It's accelerating at 1.2 meters per second squared, and the force of friction is 175 on this car. And we want to find out what the force applied is to make it accelerate like this. So go ahead and pause the clip and do this one like you did the last two. When you're ready to check, you can hit play to continue. All right, so normal force up, force of gravity down. Those are balanced. For a positive force applied plus a negative force of friction equals ma, and yeah, we can add 175 to the other side, and we'll get 2,335 newtons is the force applied, and yeah, to counteract that friction and have it accelerate at that rate. All right, so with static friction, remember it's an inequality. If you're pushing on something, right, and if like the example I did in class, if I push on a table, with 5 newtons of force, it's not moving. The friction is going to be back at me at 5 newtons. If I push with 10 newtons, still not moving, it's going to push back at me at 10. Now there's a point at which, there's a maximum. Let's say it's 12.5 newtons, and if I do 12.51, it's going to start to move, and then we've got that there. So that's why it's an inequality. It could be less than the maximum, but we take the coefficient times the normal force to get the force of friction. Now once it's moving, that's kinetic friction, and that is an equal sign. That means that no matter how fast you're moving that object across the ground, it could be moving slowly, it could be moving quite rapidly. As long as it's moving, it's going to have a certain amount of friction, and it doesn't matter if it's accelerating, constant velocity, whatever, it's going to have that amount of friction. And kinetic friction is generally less than static, right? So you can think about when you're moving an object, you want to keep it moving to, help. Because it's going to take less force to keep it moving. So this is a good one to practice here. We have a bag that's being pulled at an angle, upward angle of 30 degrees from the horizontal, and that's the force applied, which is 80 newtons. The coefficient of friction is 0.033, and we want to find the acceleration of the box. And so, we got force of gravity going down, normal force going up, friction back. And yeah, we want to find out what is the acceleration of the box. So yeah, go ahead and pause the clip and calculate or work through this one. And when you're ready to check, you can hit play to continue. All right, so we have to break up the force applied in the x and y. Positive FAX plus the negative force of friction equals ma, and then in the y, positive normal force plus positive force applied in the y plus negative force of gravity. If we set up our trig there, the adjacent side is 69.28, the opposite side is 40 newtons. So therefore, for the normal force, which we're looking for, we know the FAY is 40. We've got the force of gravity, which is negative 294. So the normal force is 254. It's a little bit less than it would be, right, if it was just being pushed across the ground without being pulled up, at an angle. So now that we know the normal force, we can place that in here for friction. We have the coefficient times the normal force. We have the force applied in the x, and we should get an acceleration of 2.0299 meters per second squared. All right, so we also practiced inclines, and so this is a no friction incline, and we have we'll want to draw our forces. So we'll do this in increments. Let's go ahead and pause the clip and draw the forces here, and then when you're ready to check that part, you can continue, and then we'll go from there. All right, so you should have two forces. You should have the force of gravity straight down. You should have the normal force up at an back, basically perpendicular to the surface. And then if you remember, after that we need to set up coordinate axes. So let's call this the positive x, because that's going to be helpful for us. This is negative x, and then positive y and negative y, right? Negative y and then positive y up there. So what we can do to the force of gravity is we can break it up into the x and y components, and in this case here we want to find the acceleration down the ramp as it goes. And so yeah, go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. All right, so we've got that set up. We should set up our normal force, positive normal force plus the negative force of gravity in the y equals 0. It's not accelerating in the y, it's just going straight down the ramp. You have the positive normal force plus the negative force of gravity in the y, and then in the x, there was only one force. And what side of the triangle is that? Well, it's the opposite side, and this angle right here is the same as this angle right here, 25 degrees. And so 25, sine of 25 times mg, which is the hypotenuse, the mg here, the hypotenuse, and we can get force of gravity in the x, which is 62.12, and then we divide by the mass, and we can get the acceleration down the ramp. All right, so now that we've done that, let's go ahead and see how we do here. If we know the acceleration down the ramp is 2.2 meters per second squared, the angle of the ramp is 32 degrees, the mass is 17 kilograms, we want to find the coefficient of kinetic friction. So yeah, go ahead and pause the clip and work through this. Draw the free body diagram first, then set up some of the forces and your trig, and let's see how we do there. So go ahead and pause the clip, and when you're ready to check, you can hit play to continue. All right, so we should have the force of gravity straight down, the normal force up perpendicular to the ramp, friction going back, and therefore we can break up the FGY, FGX, and yeah, in this case here, when we solve for FGY, which is the cosine, this is the adjacent side here, cosine of 32 times mg. Mg is the hypotenuse. So remember, cosine is adjacent over hypotenuse, and this is the adjacent side here. We should get 141.28 newtons for the normal force. And then with the forces in the x, we have the positive FGX plus negative force of friction equals ma. We know FGX is the opposite side, so sine is opposite over hypotenuse. So the sine of 32 times mg, which is the hypotenuse, will give us FGX. Then we have the coefficient that we're looking for times the normal force. We know the mass and we know the acceleration, and therefore the coefficient should come out as 0.36. All right, so what I want you to do on this one is to practice when you don't have mass. So in this one here, where the angle is 34 degrees, the coefficient of kinetic friction is 0.21, and we want to find the acceleration of the mass as it goes down the ramp. Now, in this case, you need to leave everything in variable form, and then mass should cancel from both sides. And so we want to find the acceleration down the ramp, acceleration in the x. So go ahead and now finish the free body diagram, set up your sum of the forces, and the x and y, and solve for the acceleration down the ramp. And when you're ready to check, you can hit play to continue. All right, so we've got force of gravity straight down, normal force up, force of friction going back. We could set up our sum of the forces here in the x, which equals positive FGX, which is here, plus negative force of friction equals ma. Now, this angle right here is the same as this one, so this is the opposite side. So sine is opposite over hypotenuse. So really FGX right here is FG, which is mg, times sine theta. So that's FGX, which we can place right in here. Now, force of friction is the coefficient times the normal force. Well, what is the normal force? The normal force is the adjacent side over here, which we use cosine. So cosine of 34 times mg. So really FGY is mg cosine 34, which will come into the normal force. And when we do that, we'll have the coefficient times mg times cosine 34. Mass will cancel from both sides. And in this step, I forgot to write that. We still have the coefficient in there. And therefore, we can find the acceleration of the system, and it should be 3.77 meters per second squared.